All right, let's get started. So, my name is Louis de Avila. I am a senior solution architect at Circle K, part of our global technology team, and also part of the AI Council at Circle K. I want to begin by, first of all, thanking Techeria and the team for allowing me to present on spec-driven development and how we can enable autonomous coding agents, and to also share some lessons learned from building code autonomously using GitHub's SpecKit, Claude Code, and then also with my 2 decades of experience of being a hands-on software engineer. So 20 years of engineering experience won't get replaced by AI. What it does do is it becomes the foundation that makes AI or autonomous coding in particular trustworthy and effective. So this is the frame that will follow, that everything will follow from. And what I'm hoping you can take away from the conversation here is that your experience isn't a liability in the AI area. It's actually a prerequisite. It's going to be your experience and your ability to guide AI agents that really will differentiate you from everyone else. Now, I know that some of you have already been working with AI agents. So maybe by a show of hands, can you maybe show me who has been working with AI agents already? And you can put it in the chat or, you know, okay, so a couple of little emojis, little celebrations showing up on the screen here. Okay, great to hear. So hopefully some of this will resonate with you all. Now, one of the things that I want to keep coming back to are the three words down towards the bottom of the slide: container, constitution, and craft. And so keep those in the back of your mind because we'll come back to them over and over the next 20 minutes. So what I'm showing here is a screenshot of Claude Code with a parameter called dangerously skipped permissions. So the word dangerously is appropriately named here, and most of you may think a flag like dangerously might give you like an instinctive reaction of like, I don't want to touch that, I don't want to use that. And that's a good reaction to have, because that's the point of naming it dangerously. And so what this permission does is it allows the Claude Code agent to execute commands without a human's approval. So for those of you that have used Claude Code, you may be familiar with a scenario where you give Claude Code a prompt to, for example, code a web page, and it'll go to work, and it may pause from time to time, asking you for access to a file, access to execute a command, and to do things of that nature. When we use the flag dangerously skip permissions, it won't ask for that permission. It it When you use that flag, you give the agent full ability to do whatever it wants. And so again, that instinct to be a little worried about using that flag is a natural and a good instinct to have. Our job, actually my job today, is to make that instinct outdated, not by weakening your reaction to that instinct, but by me showing you how we make it so that it is not dangerous, so that we can give the agent the autonomy it needs, so that it can go off and code, but not in a dangerous way. And we'll do that by building a box around the agent so that it can do it in a safe and effective manner. So we won't be changing the agent itself. We're just going to give it a safe space to play in. Now, before I jump into that, I want to touch on what our industry has generally asked us to do as software engineers. Typically, on a project, um, we consider trade-offs between speed and quality. Speed, I mean here in the context of getting software products out to market fast, like building MVPs or features that are maybe, not gold plated, but a little bit simpler because we want to get them out to customers fast so that the business can sell more, can deliver value to our customers quicker. Okay. Versus quality. And here, by quality, I don't necessarily mean that things are buggy. Obviously, we should all take pride in the work that we do and build things that are not buggy. But quality, I mean here, through looking at it through the lens of maybe we take shortcuts and deliver more simpler features, or we take on some technical debt and maybe don't build things that are optimized to or like our desires for scalable architecture, things of that nature. And so we've been asked to make these trade-offs for the last 30 years or more. And so today, though, it's no longer the question we should be asking ourselves: should we go faster or should we build with higher quality? Now, with the advent of coding agents and AI, and more specifically, autonomous coding agents that can go off and build things on their own, the questions we want to be asking is, do we build with structure or do we build with no structure? And so, structure means, actually, let me back up. Building without structure may mean building with technical debt at the speed of the machines, at the speed of AI. So taking shortcuts, again, in terms of architecture, like not building enough tests, not building automated tests, not thinking about what's going to happen day number two uh, once the product is released. And so we've all maybe seen this movie before. This is the way we've worked in the past. We make those trade-offs between going fast versus quality. And so I'm going to position that as building without structure. Now, the inverse of that is building with structure, building the gold-plated features, building all of the automated tests with high test coverage, building with all of the sufficient documentation, open API specs and mermaid diagrams, and also thinking about automated deployments and things like this. So all of the things that we wish we could build fast, um, now we may have the opportunity to do that. And so when we think about these trade-offs, think about them in these contexts: either building without structure, the old way, or with structure, which I'm suggesting is going to be the new way. Now, coming back to the layout of this conversation, um, remember just a couple minutes ago, I asked you to keep in the back of your mind the three words: container, constitution, and craft. When we talk about the container, I'm going to talk about where this autonomous agent will work. We're going to give it some physical boundaries so that, again, it can go off and build on its own in a safe and contained way. The Constitution, we're going to talk about how we tell the agent to build the right way. And this is where our experience will be invaluable. We're going to, in a way, teach it the shared principles that we have learned over the years, and we're going to write them down so that the agent can always use them. And finally, in the craft section, I'm going to talk more about how your judgment and your taste are critical to helping orchestrate and conduct these agents. Now, each of these layers is independent, but together we'll use them to, again, orchestrate these agents so that they run autonomously in what might be called YOLO mode, and you only live once mode, YOLO mode, safely. And we're going to visit all three and talk about how they all relate to one another and combine. So, number one, how do we give the agent the room it needs to do its work? Okay. Remember that we can launch agents and interact with them, like Claude Code, Codex, Gemini. There's many, and we can interact with them. But we may want, and I would say that we do want the ability to let them go off and code on their own without our interaction. And specifically with Claude Code, there's the flag dangerously skip permissions. And again, it's called dangerously skip permissions for a reason, because we're going to give the agent the ability to do whatever it wants. Now, when it's used well, we can, again, place some boundaries around the agent so that it is working autonomously, but not in a destructive way that will destroy the environment it's running in. Um, and so, for example, if you were to run Claude Code autonomously just on your laptop, it could, without your awareness or without you having enough time to stop it, it could delete your whole hard drive. It could search for passwords or security keys and exfiltrate them out into the internet. So we don't want it to do that. We do want it to be autonomous, but we don't want it to have that level of freedom because it's too dangerous. And so when we talk about the container, I'm going to talk about the two rings or the two pieces that make up this space where the agent can work safely. Okay. And that'll be a dev container and a sandbox. So, what is a dev container? A dev container is, to get a little bit technical here, is just a Docker container. It's like a mini operating system that can run inside of another operating system. And so this dev container, we can set up to allow uh, for that would be the space where the autonomous agent runs inside of. And so this dev container this would have access to your code repository so that the agent can read your code, understand it. It can write and save to your code repository. But then we limit the number of tools or the tool chain that it has access to. If the agent were to run on your laptop without being inside the dev container, it would have access to all of the tools installed on your laptop. Inside the dev container, we can define beforehand the tools that it has access to. So that means that we can limit its ability. Okay? So we can pre-install this tool chain, give the agent only what it needs and not more. Also, in the dev container, we can set up what's called the network allow list. So outside of the container, the agent can probably go out into the internet, onto any website, access things, download things that may be malicious, and exfiltrate code and things of that nature. Uh, Inside the container, we can tell the agent you only have access to these specific websites. For example, we might only want to give it access to GitHub so that it can upload and download our code. We may only give it access to specific APIs so that it can, get data and send data. and I'll finally give it access only to package repositories so that it can use different coding libraries. Beyond that, we can tell it you can't access any other thing on the internet. So we're limiting the code, the tools the agent can use, therefore making it a little bit safer for it to work autonomously. We're limiting the internet access that it has. Therefore, we know exactly who it's going to communicate with, limiting the ability of the agent to exfiltrate any data without our knowledge. Okay. And also, because the dev container is bound, we are not giving it access to our local physical machines like a hard drive or mounting points, to be a little bit technical. We know exactly what it can write to and read from, and that's most likely only going to be your repository or your files on the local machine for coming out of your repository. So with the dev container, we know exactly the tools, the access, both internal on the file system and external out on the internet that the agent will have access to. So we're, again, limiting the ability of the agent to do harm. The second ring is the sandbox. So there's a little bit of an overlap here in how the dev container, which is a Docker container, limits the agent's ability to do certain things with the way the sandbox works. So in sandbox mode, specifically for Claude Code, we can also tell it you can only use specific commands. For example, you can use bash, but you cannot use SSH. SSH is a tool that's used for security. Bash is a tool that's used to run commands. And so as an example, because we're running in sandbox mode, we are again limiting the tools in the toolbox that the agent can use, therefore limiting its ability to work in a quote unquote dangerous mode. So when we use the flag dangerously skip permissions all on its own, the agent has access to everything. By putting it in the dev container, we limit what it can access and the tools that are installed. And when we use the sandbox, we limit the commands it can run and the commands that it can change. And so here in the visualization, these two rings, the sandbox and the dev container, are only allowing the Claude Code agent to autonomously interact with our code repository to read and write code. And we're not granting it access to things like SSH, so it doesn't have the ability to, break our security. We don't give it access to credentials for AWS, things like passwords. We don't let it go out into the internet to potentially exfiltrate information for us. All of that is blocked based on the sandbox policy. Okay, so together, again, those two rings make the dangerously skip permissions flag actually stop being dangerous. Okay, because we have full control over the abilities of the agent. Now, we talked about how we make the agent safe to run in an autonomous way. Now let's take a look at the second word that we're coming back to over and over, and that's constitution. Okay. And this is where we shape how the agent works. We've talked about where it works in the container. Now let's talk about how it works. And here's a little bit of advice. This is where most teams probably underinvest, is in defining how the agent should be working. This is where you maybe hear a lot about how agents are not fit for writing production code or mission critical code because they produce a lot of vibe code. I would say that agents produce a lot of vibe code because they are not being told like exactly how to work. And I'm going to start going a little bit faster because apparently I've been talking a little slow and we're running out of time, and I want to give you guys time to ask questions. Um, to get a little bit specific, the tool Spec-Kit has a specific workflow where you give the agent commands. The four main commands are specify, plan, task, and implement. Specify is like writing a product's requirement document. Okay. The agent can interpret your natural language requirements of something like build a web page, and it'll build a more robust specification. Then by following these additional commands, it'll break down that work into an ordered set of steps, plans, um, further broken down by implementation tasks, and then you tell it to build, which is the final implementation step. All of that is managed by what's called the constitution. And all of these steps are reviewable by us as humans before they get executed by the agent itself. So when generating this constitution, this is where your expertise comes in. And one way that I found to be very useful about authoring the constitution or the telling the agent the how is by thinking in a cross or interdisciplinary way. Now, normally, there's a lot of members in a software development team, right? You've got engineers, you have SRE, you've got architects. And so when we build the Constitution, I want you to bring in all of your experience and the experience of your peers and coworkers into giving the first principles that the agent must follow. Okay. So to give an example of when writing these first principles, a first principle from the perspective of a principal engineers usually think about having clean interfaces or clear interfaces. So when building that constitution, you can put that as a principle that the agent must follow. Always define a clear interface. You can also bring the perspective of a security architect. So I'll always assume zero trust. You can bring the perspective of a SRE engineer. Infrastructure as code. Always build a Terraform script, for example, so that things can be deployed using infrastructure as code. And so there's a lot of lenses that you can look at the product that the agent is building. And so bring all of this experience when you're building the constitution. And that when we work on software as humans, this is where we make the trade-offs. I talked about like unstructured and structured. This is where we typically take the shortcuts. We might say, you know what, like I'm not going to write those Terraform scripts and we're not going to do infrastructure as code because, I can just log on to Amazon or Google Cloud Platform and build the services, by hand. That's the trade-off we might make to get something out to market faster. The agent doesn't care. The agent can as quickly log on, create those things, or create the Terraform scripts that will then be used to deploy in a more automated way. And so with agentic autonomous coding, we don't have to cut those corners anymore because the agent won't protest. It doesn't care. It's going to take basically the same amount of time doing it like the quote unquote easy way versus the longer quote unquote longer right way. And so we can ask it to build tests first, to do test driven development. We can ask it and force it to do accessibility and be compliant. Uh, we can tell it to do all of these things and it'll do them. Unlike us humans, we make the trade offs because we are limited in the amount of time that we can invest in building these things. I'm going to speed up. There's 5 minutes left. The governance stack, when building your constitution, this is actually a combination of things. Your first principles, those are the non-negotiables, like the lenses that we just took a look at a couple minutes ago. uh, Project guidance, this is where you tell it the technology to use. You can use things like your Claude or agents.md file. Specifically in the Claude code ecosystems, there's things like skills and rules and hooks that you can leverage to further control the agent and prevent it from doing vibe coding. And then finally, I want to talk about the craft. This is the third piece, and this is where our work goes. Okay. 4 habits that I found to be very effective when working with autonomous agents. Number one, treat that constitution like a product. That's going to give you the greatest leverage for making the agent build production ready, mission critical code. And do it in such a way so that it's measurable. So when telling the agent, don't write small files because big files are hard to read and understand. Small files is too ambiguous. Say something instead like files under 250 characters or lines of code. Okay. Restart your sessions often. Um, as the context grows, as the memory of the agent grows, the rules of your constitution sort of gets forgotten. And so restart your sessions often. And then number three, use test driven development. Do what's called red green TDD, where the test fails first because the code hasn't been written for the feature. Have the agent write the feature so that the test passes. So to me, this is a big one that can really make autonomous agents super effective. And so what this means is that we need to shift our attention up the stack, less about looking at the code. You'll still want to understand the code. I'm not saying don't understand the code, but shift your attention up the stack. So this attention should be in understanding the software development lifecycle, build your product thinking muscle, lean into design and user experience, learn some of those skills, develop your system thinking so that you can understand how your code is going to fit into bigger and bigger systems. And then finally, build your interpersonal and team and communication because you're going to be talking to more humans more. So all of these other things included along with the technical depth that you will bring. Okay? And so the meta skill here and the guidance skill here is that you're going to be conducting agents more and more, and you're going to be delegating to them the actual writing of the code. So you have to move to the layer above that, which is kind of outlined here. Okay. And then finally, from a career perspective, seek mentors, learn from your community, build more with your hands. One good way of doing that is contributing to open source projects and ask others for help. So all of this is totally doable by partnering with some of the people that you're probably meeting here in the conference. Okay. I'll skip this. This is just a little bit of a philosophy and share with you some closing thoughts. Here's my contact information, but we've got maybe people who can hang on time for a couple questions. Happy to answer questions, or follow me on LinkedIn and happy to answer questions there too. Thank you again and have a great day.